In this model, I can see the two vocal folds and the space that we have between the two vocal folds. That would be referred to as Rima Glottidis. And we can see that the vocal folds are connected to many of the laryngeal structures, including the two arytenoid cartilages. And here I would like to show you the impact that the contraction of some of the laryngeal muscles have on the movement of the arytenoid cartilages, and therefore the space that we have here, Rima Glottidis. So here we have some muscles that they are attached to cricoid cartilage, which is this large cartilage here. And also these muscles are attached to arytenoid cartilage. So we refer to these muscles as cricoarytenoid muscles. These are the posterior cricoarytenoid muscles. And then here I can see the lateral cricoarytenoid muscles. When the posterior cricoarytenoid muscles contract, what they do, they basically move arytenoid cartilages away from midline. So we can say that the posterior cricoarytenoid muscles, their contraction results in abduction of arytenoid cartilages. And as you can see quickly, when we look at the Rima Glottidis, we notice that it opens. Now, if I show you what happens when the lateral cricoarytenoid muscles contract, when they contract, they move arytenoid cartilages toward the midline. That would be adduction of arytenoid cartilages. And at that moment, we see that the vocal folds get close together, so Rima Glottidis is going to narrow down. So quickly, I show you a few times the contraction of posterior cricoarytenoid muscles followed by the contraction of lateral cricoarytenoid muscles. So we start with the posterior abduct arytenoid cartilages, Rima Glottidis open. Then lateral cricoarytenoid muscles contract, they adduct arytenoid cartilages, Rima Glottidis narrows down. So this would be basically the action of these cricoarytenoid muscles, the contraction of posterior followed by the lateral ones. And clearly we know that between arytenoid cartilages and cricoid cartilage, we do have synovial joints. So that's the main reason arytenoid cartilages are capable of such a wide range of movement. We know that corniculate cartilages, these two pointy ones, also support the arytenoid cartilages. And then the next thing that I would like you to pay attention is that inside the vocal folds, we do have elastic ligaments. We have some other laryngeal muscles that they can make those elastic ligaments in vocal folds tight or stop pulling them and make them slightly loose. When the elastic ligaments in the vocal fold, due to the contraction of laryngeal muscles, become tight, they vibrate more rapidly when air passes through them. We end up generating a higher pitch sound. However, when the muscles do not pull those elastic ligaments and they're kind of staying loose in their spot, they vibrate more slowly when air passes through them. We end up with generating a lower pitch sound. And that would be the difference in general between a male vocal fold versus a female. In male vocal fold, those elastic ligaments are thicker and shorter. So think about them as they are a little bit heavier compared to the female elastic ligaments. So they vibrate more slowly. That explains why in general and usually male's voice is a lower pitch voice. The next thing in this model that I would like you to pay attention would be the movement of epiglottis. The upper part of epiglottis, as you see, is free, but the rim of epiglottis, which is down here, should be attached to the inside of thyroid cartilage. And we know that when a mass of food and drink moves down in pharynx and gets to, for example, laryngopharynx, that would be the moment that epiglottis has to move down. And it has to stay down until the mass of food and drink goes into esophagus, which is located behind larynx and trachea. But when I move epiglottis down, then I can see how epiglottis get support from these two small cuniform cartilages that we have here. They're like two stands that epiglottis hold on to them. And obviously, as soon as the mass of food and drink moves down into esophagus, then epiglottis uses its elasticity and flaps back up. So that would be another thing that we can see in this model. Hope you find this helpful.